Hey Anthony, how's it going?
Doing pretty good.
Well, thanks for taking some time to talk with us. I know we've just wrapped up summer school. Geez, what was it, like 2 weeks ago, 3 weeks ago?
Seems
Um,
like a week ago.
yeah, that was a long week for me. So uh, after that, the summer school that we did online, I thought it would be a great idea to kind of go through a lot of the things you discussed both in Houston and during the online version of summer school, and record them and really kind of capture some of the great stuff that you shared with the guys so that we can make sure that one, they're able to be reminded of it, and two, they're benefiting from everyone's questions. And then third, of course, is that we're always growing and adding more positions and staff members. So it'd be good to be able to do a nice primer. I thought a good place to start would be with the WTC faceplate, um, and kind of go over the operation and function of this thing. So, if you wouldn't mind, can you kind of take us through, how each, not necessarily how, but what everything on this faceplate does and how it can be adjusted and tested?
Okay. All right. For starters, I'll go ahead and start off with the pH control knob. Basically, with the pH control knob, adjusting this knob will at some point activate the pH and the pH power outlet. This allows you to match the controls to the current pH of the water. Of course, pH is the measure of quality, not quantity. So by turning the knob to the lower, indicates that you desire to lower the pH, while turning the knob towards higher, it means you want to raise the pH. Also, it cannot activate the pH LED or if the pH alert or speed limits are lit. Okay. Next, we have the chlorine ORP control knob. Adjusting this knob will also at some point activate the chlorine ORP LED and the CL ORP power outlet. It also allows you to match the controller to the current level of the sanitation in the pool. Turning the knob towards lower indicates you want less sanitizer in the water, while turning it towards the higher means you want a higher level of sanitation in the water. If you cannot activate the chlorine ORP LED, or if the CL ORP alert or speed limit LEDs are lit, it won't come on at all. Okay. Next, we're going to go to the power LED. When this LED is lit, it indicates that you have power to the controller. Next, we have the pH LED. When lit, the controller is calling for additional chemicals to adjust the pH of the water. Next, we have the CL/ORP LED. When this LED is lit, the controller is calling for additional sanitizer to be added to the water. Next, we have your pH alert LED. When this LED is lit, the controller is indicating that the signal coming from the pH electrode is out of range of the pH control knob. The pH alert overrides the pH feed system. At that point, the controller cannot make pH adjustments when the pH is in alert. Next, we have the CL ORP alert LED. When this is lit, the controller is indicating that the signal coming from the ORP electrode is out of range of the CL ORP control knob. The CL ORP alert overrides the CL ORP feed system. The controller cannot sanitize the adjustments when in CL and ORP alert. All right, then we have your pH test. This is a spring-loaded switch that allows you to confirm that you can get power to the pH feed system. If the pH alert or the feed LEDs are lit, the switch will not operate. Next, we have the CL/ORP test switch. This is also a spring-loaded switch that allows you to confirm that you're getting power to the CL/ORP feed system. If the CL/ORP alert or feed limit LEDs are lit, this switch will not operate. This switch will also not operate if dip switch number 4 is on. and the position and the pH LED is lit. Next, we have your speed limit LED. This is an optional feature of your controller. When this LED is lit, it's informing you that one of the feed systems ran for 4 hours continuously. It is normally an indicator of a problem with the feed system or that of an electrode failure. The controller will cease to operate until systems or the controller will cease to operate until it's manually restarted, which is accomplished by unplugging the controller from the power source and plugging it back in. Next, we have your pH set button. This is used in conjunction with the pH control knob to calibrate when you're using pH time monitoring feature. That's a section on the dip switches. Next, we have the meters. You have 2 individual LCD meters continuously displaying ORP and pH reading. The ORP is a millivolt reading. Next, we have your cab. This is the bottom right, and we have this on a few of our models. The small screw allows you to calibrate the pH meter only. It is very limited in the range. The controller must be properly calibrated before adjusting the pH meter. And that's pretty much everything on the face panel.
Okay, so looking at a couple of these features, kind of going a little more in depth. pH set, so that is not going to do anything unless timed monitoring is selected on, what is that, dip switch 2?
1 and 2 in conjunction.
1 and 2 in conjunction. So for the water management program, those are always going to be in the off position. And correct. So the pH set button would not do anything if those are off, correct?
Correct.
Okay. And then going into some of these alerts a little bit, if the pH alert, when is that going to illuminate? When is it going to go into pH alert?
If you have a low pH, that'll activate and it won't allow any feed from the pH receptacle.
So the range on the pH is the same for both boards. It's different on the ORP side. But that alert is going to go in when it's, what is it? Is it 1 pH unit below, or is it a half pH unit below? I forget.
That's going to be 1.
So if they've got a set point, so if they've got a set point of, say, negative 28 millivolts, then if the controller was to be at positive 28, if the probe was reading positive 28 millivolts, it would go into alert.
Right.
And then does it automatically clear on its own?
No. It only automatically clears with the ORP.
Okay.
And you actually calibrate the out of alert. So to get the pH out of alert, you unplug the unit, plug it back in, and do a power cycle.
Okay. Now, is that because it won't ever reset, or isn't there like a 2-minute delay or something? I thought on it.
On the pH, no. Now there's a 1 minute. Now if it's below the threshold, you have 1 minute to get it back up over that threshold before it actually comes back on.
Okay, so that's for, like, say a customer was to manually add some acid to the pool, and some of that acid was to maybe go down the main drain or the skimmer line, and the pH drops for a short period of time. It's delaying going into alert, but it isn't going to come back out of alert on its own.
No, it's not going to come back out of alert on its own.
Okay, very good.
If you add it to the main drain or the skimmer that quickly, it should shoot right down and go right into alert.
Right. Okay. And then on the chlorine or CLORP alert, I hate saying chlorine when we're feeding bleach, but obviously it's trying to synthesize a free available chlorine residual. So that alert, you said that it will clear on its own if the ORP comes back into range?
Right. Or if you have the number, that's going into the dip switches. If you have the number 3 dip switch active, it'll actually go into alert. Now, if you don't want it, continue to feed to get it back up, you just leave number 3 to the left, which is default.
Okay. Yeah. So
I don't
they
think you guys use that out of field.
yeah, that should be staying
Right.
in the off position. So and now, when does that activate? When how many millivolts below? Now, doesn't it go into ORP alert if the ORP is too high? If dip switch 3 is off?
Right.
Right.
Now with the high alert, let's see. Yes. And I believe that's the same thing, 100 millivolts below or 100 millivolts high.
Okay, so if we have it off, it's going to be a high alert, and that's going to be if the sanitizer residuals gets too high, it'll go into alert, and that one clears on its own.
Correct.
So they don't have to unplug it to get that to reset. Very good.
And you can actually calibrate that out of alert as well. Like with the pH, like I said, you have to
Right.
unplug that again for any alert on the pH side.
Right. So if it was a false high, meaning that yes, the ORP reading for the controller is high, but for the actual residual in the water, it's where we want it, we would just adjust the set points, and at that point, the alert would clear.
Correct.
Very good. Okay, and so I think that's most of what we wanted to cover on the faceplate. Now, we talked a little bit about this pH monitor calibration screw up in the top right-hand side. It's got a very limited range, so they shouldn't be messing with that until like the last step when they're done, right? They've got their pH, everything is set and ready to go, and then they can just give it a little quarter turn or so, just to.
What I like to tell guys to do is you want to calibrate. First of all, test your pH first. Once you test, you do an internal calibration first,
Right.
and then external lastly on the face panel, because that one just calibrates the digital readout. So you basically matching that to your test kit reading.
Right.
So say for instance, and you calibrate internally on VR17.
Mm-hmm.
Once you have that set point, next you would calibrate on the face panel so that they can tweak it in to match your test kit reading.
Great. Yeah, so it's really for when the controller is saying 7.48 and the pH is 7.6. It's not for changing it when the controller says 7.8 and your reading is 7.2.
Correct.
Right. So let's switch over to the Redboard view. It's going to take me a second to pull this up on my Chromebook. And so now we have a picture of one of the boards. This is a Redboard, and I thought you had some really good insights this year for the team. A number of things that I had not heard before, and I was really impressed that we were sharing it with the guys and getting them to be more prepared in the field. So I don't know how you want to start with a view of this, or maybe we start with just an overview of the major components. Where the stuff that they would service would be, or that they would check. You want to start in the top left-hand corner and work our way down?
Yeah, I'll go ahead and start at the top left. That's going to be, of course, your transformer. And if you go right below your transformers, you have your relays. The relays transfer power to the pH and sanitizer feed system. The relays plug into the circuit board and are pretty much easily replaced. Next to the right of the relays, we have the fuses. All the fuses are electronic, slow blow, top fuse. Depending on the color of the circuit board, this was going to be a 1/8 amp fuse. On the older blue boards, it's going to be a 1/4 amp fuse. The top fuse powers the controller. The middle fuse is a 3 amp. Powers the pH feed system, and the bottom fuse is going to be a 15 amp or even an 8 amp, depending on the color of the circuit board, and this powers the sanitizer feed system. Next, we're going to go to the top right-hand corner, the red rectangular box, white switches. Those are your tip switches. This allows you to choose the optional features for operating your controller. Now, if you go right below the dip switches, there's an active toggle switch. Depending on the circuit board you have, the red board or blue board. On the red board, just coming off of the side, and on the blue board, just going to run vertical. And this is basically acid caustic. Some of our Aquasol customers use a base, in which case that actually raises the pH. But for pool shores application, they use acid. So you always want that in a down position on your body of water. If you go about 1.5 inches to your left of that, it's going to be your calibration screws. VR16 and VR17. These are used to calibrate the face panel, control knobs, on the front face panel. And those are pretty much all the main components of the circuit board that you guys will be using out in the field.
Yeah. So diving into a few of these things, obviously we had talked about the relays, and it's an interchangeable part, right? So it's no different relay, whether it's a blue board, a red board, a pH channel, a ORP channel, correct?
Right. So basically, if you're having a trouble with your, let's say, your chlorine feed system, but you know everything is working for your pH, it's fine to actually start off with first thing first, changing out that relay, since you know the ORP feed system relay works.
Right.
And just doing that by process of elimination.
Right. And then we move from there to the fuses. And now the fuses are they upstream of the relay or downstream of the relay?
Repeat that again?
Are the fuses for the ORP and pH, are they before or after the relay?
The fuses, I believe they're before the relay.
Right. So if you were so if you didn't hear the relay clicking on and off, it could be the fuse, because the fuse is before the relay.
No, I correct that. It was still activated. The relay was still activated.
Okay.
So that would mean it was. So you still could have a bad fuse.
Okay. So you could have.
Still activated.
Right. So the power is come. So when the controller says, "Oh, I want to feed sanitizer," it's going to, that relay is going to close even if the fuse is tripped, but they wouldn't get power to the pump because the fuse is blown.
Correct.
Okay. Very good. And so that would be a good indication for them. If the light's coming on and the relay is clicking, but they're not getting any power, they could go right to the fuse.
Right to the fuse.
Yeah.
And lastly, if it's not the fuse, it's going to be something within that actual receptacle or even the spade connectors on the receptacle.
Very good. And then we were talking, you talked a bit about the acid caustic selector switch over on the right-hand side of the board. And with the caustic, that's because we're marketing this controller to the pool industry as a whole. Aquasol is. And Poolshire's operating area is really along the Gulf Coast. We're using bleach. Bleach has a high pH, so we're going to feed acid to control the pH. But in some areas, they might use, say, trichlor or dichlor with a low pH. I suppose they could even use gas chlorine. We have a line of gas chlorine controls.
Correct.
So that would be for feeding a caustic in order to bring the pH down, because their pH, or they bring their pH up because their sanitizer would naturally bring the pH down. Is that correct?
Right. And by flipping that switch, you actually calibrate opposite. So if the feed light were on, the pool shore, you would go clockwise to get it to go off. Now it's just the opposite of caustic. If the feed light is on, you go counterclockwise to get it to go off. So by flipping that switch, it's the complete opposite.
Absolutely. Yeah, it's funny you bring that.
Sometimes in the field, I activate.
It's interesting that you bring that up. I always knew instinctively what that switch did, but I had never thought about the fact that when you switch it, the adjusting the set point is gonna reverse. In my mind, it was. That I was still thinking it's the same thing. And it is. I mean, it's not like it's any more difficult to do, but you would be turning the knob a different direction. Interesting. Now, kind of to wrap up and get into, and I know we're going to get into this a lot more with the next video, but the low power side of the controller, so the transformer, the capacitors, etc. You'd given some interesting information during training about temperatures and voltages, and so what are the guys looking for there when it comes to the transformer and the capacitor? If they're having issues with the controller and they're not really sure what to do next, they know it's just not behaving properly, and they've maybe called you. What are the steps you're going to walk them through there with that transformer and the capacitors?
The first thing would be a physical inspection of the transformer and the capacitors. Sometimes you're able to tell by looking at the capacitors if they're bloated at the top. That's a telltale sign that you have a power supply issue. Another thing with the transformer, it actually has shrink tubing. And if you see that shrink tubing is melted or even damaged sometimes, that's a telltale sign that that transformer is failing or has failed.
Okay.
Now, as far as the voltage, that would be a thing with the voltage regulator. It's right next to the capacitors. And you have a positive 12 and negative 12. Now, if they get to about 11.8 volts, then the board starts to heat up, in particular on the voltage regulator. And when voltage drops, the amperage increases. But once that amperage increases, it causes the relay to chatter back and forth, and to a certain extent where it actually melts together and even melts the relay socket as well.
Yeah, so that's probably a thing to possibly thinking about checking with our PM procedure. Maybe we can work together to come up with a testing for that, because it sounds like that'd be a pretty big danger for if one of those fuses or relays was to fuse in the open or closed position. It could cause an issue.
Correct.
Very good. Very good. And then one last thing, I know the answer to this question, so but I want to hear you say it. The VR16 and VR17, those are respectively which feed channels, and what are those little blue boxes called?
Those are potentiometers. VR16 is for the chlorine ORP calibration. VR17 is for the pH calibration.
I swear I knew that.
They're called potentiometers.
Yeah, and so those are what's going to adjust the set point as the screw is turned, and then on the red board, you're going to end up with a 20 millivolt leeway per notch, right? And the blue board is 40.
Each notch on the ORP, blue board is 40 millivolts on the ORP side. Like I said before, pH is the same for both circuit boards.
Right, pH is the same. Very good.
Now, on both VR16 and 17, they do have an internal stopping point.
Mm-hmm.
But external, you can turn for days and the screw won't come out. I get a lot of our Aquasol customers that are actually turning in small increments because they think the screw's going to come out. So that's another pointer. Screw won't come out.
Good to know. Now you will, if you listen real closely, you can kind of hear it tick, right? When it hits its stopping point of like it's not going to adjust anymore, right?
Right. Some of them do, some of them don't. But I even have red boards and blue boards that don't click. They just turn.
Okay.
But it still has a stopping point. Now the one that doesn't, that does have an external and internal stopping point is the one right below the pH display, the pH cal.
Mm-hmm.
And sometimes we have that come back from after where it's stripped out. Now those do have a stopping point.
Yeah. So
the WTC meter.
Yeah.
You don't want to turn that past stopping point because that'll cause your pH readout to fluctuate.
Yeah, absolutely. So that little screw, real light touch to it, right? I mean, we've all turned them. If it doesn't want to move, it doesn't need to be moved, right?
Yeah.
Very
Correct.
good. Very good. Well, Anthony, thank you so much for your time. I appreciate you being able to jump on with me and do this. I always appreciate getting to spend some time with you and do these sorts of things for the guys. I always learn something. And unfortunately, we couldn't do it face to face, but it's probably better for the guys because they got a clearer view of the equipment.
There you go. Anytime.
All right, very good. Thank you.
No problem.